So this first part is just talking through. I don't know why this is so dark. Can you see this okay? Because it's on your paper, so. I know. Okay, you can do the light off. Well, I don't know. I feel like it's going to be really dark in here. You think you can see that better? Really? Oh, that's a little bit thicker. Right? Okay, so here's the situation. So after experiencing swelling in his shoulder, Jack began to take anti-inflammatory drug. His doctor prescribed 200 milligram dose every 6 hours until the shoulder healed. Here's an important piece. 20% of the medication dissipates each hour. How many hours does it take until Jack can take another dose? Now I'm going to look at 160. 6 hours. So it's 20% of the last amount each hour, though. So let's look through the table because they filled in the information for you, but you need to know what they did. They take dose number 1. They started with 0 in their bloodstream, so they have 200 in their bloodstream. So they went from 0 to 200. The net change is nice to know, but okay. So then what happens? How do we go from 200 to 52.4 right before taking the medication? Well, if you just did 200 times 80%, because right, 20% dissipates each hour, 200 times 80%, there still should have been 160 left, but that was only for 1 hour. So you need to take 200 and multiply by 0.8 raised to the 6th power, because it's 80% of 80% of 80% of 80% for 6 hours, right? We're losing 20, so we're retaining 80. So that's where the 52.4 is coming from. It is this last number times 0.8 to the 6th gives you the 52.4. Then they add 200 with their new dose. So the net change is just, we can see that we went from like 200 to 252.4. So that's the net change is 52.4. 252.4 is what's in the bloodstream. That dissipates now for 6 hours. So we do 252.4 times 0.8 raised to the 6th power for 6 hours. That's where the 66.2 comes from. Add 200. There's your net change. The 52 to 66 is that 13.8. Then 266 dissipates for 6 hours. Add 200. So it says how much anti-inflammatory will be before he takes his 5th dose of medication. So let's just fill in the last row there. So 24 hours. He's going to take his 5th dose. What number goes right there? So you're going to take the 269.8 and multiply by 0.8 to the 6th. Does that make sense where 0.8 to the 6th comes from? If it was just 1 hour, you only have to do it once. So 269.8 times 0.8 to the 6th. So I get 70.7 milligrams, right? All right. How much will be in his system immediately after he takes his 5th dose? We just add 200, so 270.7. And what is the net change? So we're just subtracting basically the 270.7 minus the 269.8, right? So the net change this time was only 0.9. So it's changing less and less. It's plateauing in the bloodstream. So it's an important thing for a pharmacist to know how much medication do they need to not have pain, and we don't want them to like overdose. But if he took it every hour, he might have too much in his bloodstream, right? Because it's not dissipating fast enough. So it's an important thing to know, like how fast it dissipates, how big the person is. It changes how often, the frequency of the dose, what's their pain tolerance. So it says, does the net change, the 5th column, converge or diverge, would you say? So converging means it's getting smaller and smaller and smaller. It's converging, right? Because you're eventually adding a net change of 0. All right, so then they give you this equation. The net change in medication can be modeled by this function. This is the starting value 200. This 0.262, that's just 0.8 raised to the 6th. Wait a second. Yeah, see my 0.262? That is 0.8, 80% raised to the 6 hours is 0.262. This is 0.8 to the 6th right there. That's what the ratio is. And I feel like it's hard to see because it's so dark in here. There we go. So starting value times your ratio, that 0.8 to the 6th, and then they're raising it to the n minus 1 power. So it says estimate the change in medication between the 30th and 40th dose. Round your answer to the nearest hundredth of a milligram. When you do these out, it's going to be next to nothing. So let's just do it in our y equals menu. 200 times 0.262 raised to the n minus 1, or x minus 1. Go into your table and just grab 30 and 40 and see what you get. You're just plugging the function in and then seeing what you get for 30 and seeing what you get for 40. Right, so that's 0. It's approaching 0.00000000001. So it's about 0 already at 30 and 40. All I did was I put in my y equals the function in question, and then I went into my table to row 30 and row 40. Second, I always do second table setup is above window, and second table is above the word graph. So 0 is the net change. It's going to plateau. So, no, I went to second table setup first, and I told it to start at 30. In your y equals, did you do 0.262 to the n minus 1 power? Yeah, so that means it's insignificant. It's 0.00000000003. So it's a net change of about 0, right? And then the last thing they want you to do is use that geometric converging formula that I just put on the board, and they want you to find what it's going to max out as. So it's the first term divided by 1 minus the ratio will give you the infinite amount in the bloodstream. So we're putting in 200, and then the ratio is that 0.262 number. So it's going to max out at pretty much where we already are. Make sure you put the denominator in parentheses, but 271 is about where it maxes out. So we're almost there by row 5, right? We're at 270.7. So no wonder by row 30 and 40, it's going to just be 271, 271, 271. So this was to try to figure out what the ratio was, to try to learn about converging or diverging, to think about what the infinite sum was. On the back page, I'm just going to help you draw a quick sketch of what this situation would look like without thinking too hard. But we know that the highest point is going to be around 270. So I think counting by, is that 20 going to be 25 then maybe? 25, 50, 75, 100, 25, 50, 75, 100. Nope. So how about count by 50s? 50, 100, 150, 200, 250, 300. Just to get a rough sketch, this is my milligrams concentration. If you notice the bottom, we only want to fill in 6, 12, 18, and 24, right? Because that's when I take a new dose every 6 hours. Oh, and 0, right. So here's the way I want you to graph this. I want you to graph the starting and the ending for each of those time frames. So at time 0, we actually jump from 0 up to 200, right? Because I started with 0 and I took 200 milligrams. And then it kind of goes downward, maybe not linearly, but it goes downward to what? 6, 52.4. So it goes all the way down to 52.4, and then it jumps up to 252.4. So it kind of goes down and then back up again. I'm just drawing it this way to show you the upper and lower trend of kind of the medication in your system, because this is what the doctor or the pharmacist might think about. So at hour 12, what was it at? It was at 66.2. So up a little bit, but, and then 266.2, something like down and then back up. Obviously, this is not a function because I'm just drawing these vertical lines. And then at 18, it's at 69.8, so almost 70. And then 270. And then it's kind of staying the same and then going up to the same, about like this. Down, up, down, up. So you can kind of see like the upper level of the medication and the lower level of the medication, right? So if the patient came back and said, oh, by the end of my 6 hour, I can't even stand up, or whatever, is the shoulder. I can't get out of bed by hour 6. They would think, oh, well, either it's dipping too low down here, right? We don't want them to get below 100 milligrams or something. Maybe we can shorten the number of hours, or we could increase the dosage. So what I want you to do is I want you to try to adjust the medication so that the level stays between 100, so it never goes below 100, and it never goes above 300. Right now, we're pretty good on the upper end, like they're at 270. So see if you can either play around with the number of hours, that would change your ratio, or the starting value. Or sometimes they might have you take like maybe a double dose at first, and then, you know, just take a single dose thereafter to try to keep the level in your bloodstream at a certain level. So I'd like you to just guess and check. So pretend you're the doctor. What if you prescribe, like if you each just tried one different scenario? So for example, what if you kept it 200 milligrams, but you changed it to 5 hours? How is that going to change the maximum? What if you increased it to 250 milligrams, but you kept it at every 6 hours? Just take a guess and just see how it changes. You don't have to come up with the answer on your own. Well, 0.8, yeah, you have to raise the 0.8 to the number of hours. So if you're going to change the number of hours, yes, because that's the 80% in your bloodstream. You need to change the exponent of the 0.8 if you're going to change your hours. So just, you know, play around with it. See how close you can literally get to like 100 minimum, 300 maximum. How close could you get? You don't want to overdose the person.